Okay, so let's begin. So, hello everyone, a very good morning to all of you, dear authors, and all the invited guests. A very warm welcome to Technical Session 7A. Myself, Yashita, and I'll be your moderator for this session. I'll be making sure that everything runs smoothly and maybe try to keep up your energy till the last. So, on behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you all to the 11th International Conference on Information and Communications Technology for Sustainable Development, which is ICT4SD 2026 Goa. The 11th edition of the conference is being organized in a hybrid mode. So the physical event is being held today. It was held yesterday on 9th July, and the virtual event is being held through Zoom from 9 to 11th July, where people from all over India as well as many from other countries are present with us. So I hope that you all enjoy today's insightful and knowledgeable sessions. So in this session, we will be having a total of 10 presentations, and each presenter will be given 10 minutes for presentation, followed by 2 minutes for question and answers. And I will give a gentle reminder at the 8th minute mark just to keep everyone stay on track. Also, small request to all the participants, please stay connected with us till the closing remarks. We promise that it will be worth it. And also, if you have any queries or updates to give, please feel free to drop them in the chat box anytime. Me and my co-host will be assisting them. So before we begin, I would like to introduce everybody to our esteemed session chair for today. We have Dr. Ranjit Kagade, who is a lead consultant Everforth QNOX, specializing in generative AI and data science. With over 4+ years of hands-on industry experience, he has designed and deployed intelligent AI solutions across insurance, automation, and cybersecurity domains. His expertise includes machine learning, deep learning, CNN, RNN, LSTM transformers, auto ML pipeline, and robust MLOps practices. So, welcome to the session, Ranjit sir. Do you have something to say to start the session?
Thank you for the brief introduction. You can start the session.
Sure. Okay. So, for our first presentation, we have Yashwant Kumar. Yashwant, are you present in the meeting?
Yes, ma'am. I am audible.
Yes, you are audible. So, Yashwant is here to present his work titled as An Intelligent Computer Vision Framework for Food Quality Evaluation and Safety Analysis. So, Yashwant, you can start sharing your screen.
Okay. Is it visible to all?
Yes, it is visible. You can start.
Hello. Good morning, everyone. I am Yashwant Kumar. From I am Yashwant Kumar, PhD scholar at NEPM Kundli. I am working under the supervision of Dr. Kumar Rahul. He is associate professor in NEPM Kundli. Today in my presentation, my topic is an intelligent computer vision framework for food quality evaluation and safety analysis. And the contents of the topic is introduction, literature review, problem statement, and the proposed methodology, discussion, conclusion, and the questions. First of all, I am starting from the introduction part. So let us understand about the computer vision. What actually the computer vision means. Computer vision basically is a subset of AI that enables machines to see and interpret visual information, to make some tasks like sorting, grading, and detection in fruits uh, based on their texture, color, and their ripening stages and all. This model is basically based on AI. So we understand about AI based computer vision system that will provide a deep inspection for food quality and safety, that will enable high speed real time analysis in farms as well as factories, industry, so that the spoilage can be reduced at early stages. So first of all, we need to understand why we need intelligent computer vision thing. According to the Food and Agriculture Organization of United Nations, the study at 2022 expected that the global population is expected to reach around 9.1 billion by 2050, and the wastage of the food products and fruit products are increasing day by day due to high demand of the fruit products. The population is not going to meet the proper food item or fruit items. Uh, so out of 793 million population, one person is every nine suffers starvation daily. So food demand worldwide is increasing, and maintaining high quality food in today's rapidly growing market and meeting the dietary energy requirements of a growing population have become significant challenges worldwide. The rapid spoilage of perishable food, including fruits and vegetable meats and seafoods, dairy products, is largely due to their high moisture content and biological composition. So we need intelligent computer vision framework to reduce these wastage at early stages. These are the applications of AI-based computer vision system in food and agriculture sector. So first of all is segmentation technique. It will help to identify and separate objects through the images of different fruit, and the ripening detection based on the texture, color. It will also tell you about the freshness prediction of the fruit products based on its texture, color, and the smell of the food products. Either it is fresh or bad. Now it will also detect the adulteration based on its impurities, quality control in packaged food and beverages. It will check either the proper labeling has been done or not, and then feature extraction, defect detection, and grading of the system, and nutrient analysis of the system based on their composition, chemical composition of the food products. These are the basic applications of AI based computer vision system. Now, these are some key opportunities and limitation. First of all, key opportunities as quality and safety inspection, as I have earlier told you, like according to their texture and their color, we can easily predict the quality of the food products. We can also inspect the food hygienes and monitor it easily. And by using AI-based computer vision, automation can be easily, and the defect can be easily identified. Packaging level verification, supply chain, and inventory management with the help of images. Now the limitation is technical and implementation cost. To implement the AI-based computer vision system in a small kind of farm or industries, the implementation cost may be high, and the scalability. That means if we are implementing the computer vision system in the existing industry, that is already working on the manual based, then all the system may not be scalable to adopt the latest AI based system. So we need to uh, change all the system according to the AI based model. Now data management is also a challenge. So we have to implement the big data analysis, or we have to purchase more amount of storage for data management. And workforce transition and lighting and reflectivity is also a challenge for the computer vision system. These are some literature review from where I have uh, studied and given the framework for computer vision system. So these are some studies that are from year wise, like 2025, 24, 23, and 22. Some of them, like author Lee et al., has worked using machine learning, computer vision, sensor, and robotics. They have taken a product like trace food, meat, seafood. Their key findings are robotics and computer vision integration for automation and quality assessment of trace food, meat, and seafood. But they have faced challenges like their data set needs to be improved, and some latest model like explainable AI needs to be implemented. And another author has used method end-to-end framework, microservices, yellow, computer vision, DCI, OCAR technology for food packaging, quality assessment for coffee packaging. They have find out the modular architecture and hybrid tail computer vision system, improved adaptability with fast inference and data centric cycle. But they have faced challenges like alignment of acquisition, region of interest, runtime, deployment, and so on. These authors have also find out some findings and challenge. Now the major problem out of some research study, that is lack of real-time monitoring. That means inability to access perishable fruit quality, microbial contamination, spoilage and visual defects causing food reports and sale. Another is rarity of critical defects like bruising, contamination, or foreign objects occur infrequently. That makes the data collection and detection difficult. And then higher speed production challenges in food industries and beverages industries. The pro- uh, mm, the production of fruits and beverages lines process hundred or thousands of units per minute requires instant inspection and decision so that no error can occur during the production. And then finally, need for automated, scalable, and non-destructive solution. That system lacks in continuous, automated, and non-invasive monitoring for effective quality assessment. Because non-destructive solution always find out the surface level of defects. So these are the proposed framework where I have outlined an end-to-end production ready pipeline for automated food quality assessment using AI-driven.
Yashwant, sorry to interrupt. There's a quick reminder that you will have to wrap up within next 2 to 3 minutes because it's already time up. So you
Okay.
just need to summarize the rest part. Yes.
So basically, this system will work on like RGB image and sensor that will RGB images using the camera module. It will take color, shape, texture, and surface, and the surface module it will find out the aroma patterns, gas concentration, like ripe, spoil, fermentation, heatation. For image processing, resizing, and scaling, removing noise, and data augmentation will be there, and then sensor processing for noise and smoothing and normalization, and then for image processing there will be grad cam that will help to uh, highlight the important regions of the images like heat maps of the images. And then for gas sensor vector, learn relationship between gas concentration suitable for sensor data and the suitable when sensor reading changes over time. And then it will over the combine both the feature fusions, and it will take the decision based on their quality, uh, safety, and they will predict the shelf life of the product. And then finally the decision support system will be there that will either it will identify as a safe or reject. And these are the discussions of the study, like problem scoping and data strategy, sensing and acquisition, processing and synchronization, feature learning and deep learning inference will be there, rule augmentation, decision fusion, and decision and operation action and documentation, and learning loop and emerging enhancement. These are the conclusion of the study, like AI-based computer vision enables precise and non-destructive and scalable food quality assessment. Integration of multimodal sensing improves defect detection by capturing both surface and subsurface characteristics. It will take both uh, characteristic for surface and for internal part too. Deep learning with rule-based reasoning ensures faster, transparent, and standard compliant inspection decision. Overall, the coverage of AI sensing technology and regulatory reasoning can deliver safer, smarter, and more suitable food systems. And these are the references, top 5 references where I have implemented this framework.
Thank you so much, Yashwant, for presenting. Ranjit sir, do you have any questions for him?
Yes, the overall presentation was very nice. But my question is that what are the limitations of using AI in such a food quality check and all the details?
Sir, the basic limitations is like if AI will be trained wrongly, then it will predict the wrong prediction for the fruit quality.
Yes, what?
Or
But human intervention is required, I think.
yes,
100% automation is not
yes,
possible.
yes,
Am I correct?
yes, sir. Little bit human intervention is required because if fully automation will be there, then not maybe uh, every production will be correct.
Okay. Just consider that if 100 people are there working for quality check, by implementing the project, whatever you are saying, how many people are sufficient out of 100?
If we are implementing this system in industry, then most probably uh, ma- uh, main person will be required who is quality inspection around 5 to 10 people only.
So you are saying that out of 100, only 10 people are required,
Yes,
right?
yes,
Now coming back to the budget part, if we have a budget of 10 lakh rupees for this quality check for a year, then
yes.
if we implement the project you are saying, if we implement that, what will be the total cost including 10 people and AI cost?
Basically, sir, in starting, I have already told you about the limitation part. The technical and implementation cost is high for implementing this AI-based computer vision system for a small industry. So these are the major parts. So we have to consider it.
Okay, thank you very much.
Hello.
I have done with my questions.
Thank you, sir.
Okay, sure. We will move on to the next presentation. So our next presenter is Heer Pathak. Heer, are you there in the meeting?
Yes, ma'am.
Yes. So she is here to present her paper titled as Comparative Analysis of Deep Learning Techniques for Satellite Image Classification. So you can start sharing your screen here.
Okay, ma'am. Am I audible?
Yes, you're audible.
Thank you.
Yeah.
Screen is visible, ma'am. Which I share
Yes,
it.
you can start. You're on mute, I guess, here. Is there any issue you're facing?
Ma'am, maybe for the network problem, I'm sharing my screen with you.
Yes, the screen is visible. You can start.
Okay, okay. Thank you, ma'am.
Mm, mm.
So, good morning, everyone. Myself, Heath Pathak, and today I am going to present my work titled Comparative Analysis of Deep Learning Techniques for Satellite Image Classification under my guidance of my mentor, Professor Rikita Choksi from Charuset University. So first of all, we start with the like I choose this topic. Satellite image classification is an important area of remote sensing because it helps us identify different land use categories such as forest, river, sea lake, industrial region, like that. In this paper, we compare four models: ResNet 50, EfficientNet B0, Vision Transformer, and GeoCNN to determine which model perform based perform based on my dataset, which I used is Euroset dataset. First of all, let's start with the introduction. So, satellite continuously capturing images from the Earth's surface from obtaining sensor, and these images contain information about land, water, vegetation, industrial, and as well as agriculture fields data, and uh, traditional traditional machine learning algorithms like support vector machine, random forest, and uh, uh, MLC we used, but these methods are required manual feature extraction, like for finding edges, curves, and for that you need to extract the feature manually, so do not perform well on very large and complex data set. So I used this four deep learning models which are performing well, and it is good for this complex large data set. Here is my literature review. This slide summarizes previous research in this field. Like many researchers have proposed different deep learning methods for satellite image classification. These are the authors which I mentioned, and they use a different data set. Some like one is use a SAR multi-resolution data set, remote sensing satellite images, and different types of model, and also used hybrid models for higher accuracy, higher resolution image to see, which is based for remote, which is based for the remote sensing. And most study achieve good accuracy, but each had certain limitations, like such as a high computational cost, difficulty handling complex senses, or requiring large data set. After I study this paper, go through this paper, we decide to compare uh, different type of four deep learning models under the same conditions, same pipeline, to identify which is performing the better on the on this data set. I used Euroset data set because it is a benchmark data set for land use land cover classification. And second one is it is having a 27,000 labeled images across 10 use classes. So I used this, and each image is originally 24 into 24 pixel, and is captured captured using the Sentinel-2 satellite. So this is a very better for real world image classification. And which records information in a 13 spectral bands. This figure, which mentioned on this page, is on this slide. Sample images from my data set of 10 different classes, like crop, forest, vegetation, highway, industrial area, permanent crop, residential area, sea and river water body area. So next is methodology, processing and training. So the first step is image resizing, since pre-trained deep learning models required larger input images, like they are automatically extract the features from the raw images. And first, all image my images were are 64 into 64 pixels, so I converted all these images into 24 into 224 into 224 pixels. And next we perform the normalization, where pixel values are scaled between 0 and 1. By we scale it between 0 and 1, so this makes model training faster and more stable. Then we applied data augmentation, like random flipping, rotation, contrast changing, and blurring. And then we after this processing, the data set is divided into training and validation. For uh, training and validation, the models are trained using the model are training using the PyTorch, which PyTorch framework, and GPU support, which I mentioned in here. And this data is available on the Kaggle. And we use optimizers like ADAM and SGD with cross entropy loss for multi-class classification. Then we used transfer learning. Transfer learning, why we use transfer learning? So the model already contain knowledge learned from the ImageNet dataset. So learn faster, and for achieving the better accuracy, we used transfer learning. And finally, for evaluation, we use accuracy, precision, recall, and F1 score, and confusion metrics. Let's start with the model which I used in my research. So first of all, I used ResNet 15. ResNet 15 is most widely used CNN architecture, and it resolves the vanishing gradient problem. It is a better scaling for satellite image classification. This convolutional layer automatically learns the scaling, outlines, and feature extraction. So it will be giving a better accuracy for satellite images. And my second model is Geo Spectral CNN, deep learning model. This deep learning model is specially designed for satellite imagery, unlike ordinary CNN, like simple CNN. Geo CNN learns both spectral and spectral information, and this both information is important for the satellite images. Spectral information tell us about the location and shape of the object, like road, river, buildings, like that. And whether the spectral information comes from the multiple wavelength bands captured by the satellite. So basically, GNN combines both type of information, spectral and spectral information, and using convolutional layer, batch normalization, and railway activation. My third model is vision transformer, VIT. The third model is VIT. I use because vision transformer does not use any convolutional layers. Instead of that, it first divide the images into many small patches. Like first, it take image as an input and divide it into the small patches, and each patch is converted into a numerical vectors called embeddings, which I'm mentioning in my figure in architecture. The most important part in a VIT is a self attention. Like self attention allow the model to understand relationship between different part of the images, and it strongly at global context, but perform based with the large training data set. My fourth model is EfficientNet B0. It is a CNN architecture that scale not only a depth, width, or input resolution, but it contain this three scale these three: network depth, width, and image resolution together using compound scaling coefficient. Like instead of increasing only the number of layers, EfficientNet balance these three factors together. This like by balancing the scaling allow the model to learn efficiently without becoming the unnecessary large. Like this all four across I use these four models, but my this model EfficientNet B0 which I used, this is giving a better accuracy among that all the model. And after training, uh, i I see the result by comparing
Okay,
this
here
four
there's a quick
models.
reminder. You will have to wrap up within next 1 to 2 minutes.
Okay.
Yeah.
EfficientNet B0 giving a 98% accuracy, and giving a highest accuracy among these four models. EfficientNet B0 is a best performer, and then second is ResNet 50, 97% accuracy, strong spectral and spectral running. Vision transformer is giving 94% accuracy based global feature capture, and GeoCNN is giving a less accuracy among that all four models, like comparatively limited feature extraction for my dataset. And this is a confusion matrix analysis. So a confusion matrix compare the actual class with the predicted class. As you can see, the diagonal value represent correct prediction, which are the correct prediction, while the off diagonal values represent incorrect prediction. And as you see, efficient B0 has the highest number of correct prediction and the fewer misclassification. That's why the that model is giving a better accuracy. Then training and validation accuracy. The blue curve represent training accuracy, while the orange curve represent validation accuracy. When both curve remain closer, like both curves are remain together, indicates that model generalize well. If in some case gap become very large, so indicates overfitting. One slide is for the abbreviation study. This demonstrate that transfer learning is most important component in achieving the higher accuracy. And these are the challenges which I faced during the research. Although deep learning performs very well, but satellite image classification still faces several challenges, like cloud effect, shadows, atmospheric condition, and sensor noise that is reducing the image quality. And second is high spectral images contain hundred of spectral bands, like there are 100 of spectral bands, which making computational very expensive, like number of images are there and a very large data set. So, and some blend use classes like look very similar, making accurate classification difficult. So some classes are looking same, so there is a in a classification that is not giving a more accurate result. And I would like to conclude with that all models were trained under the same processing. We use the same pipeline and evaluation condition to ensure that for fair comparison among all the models, EfficientNet B0 achieved the highest accuracy, which is 98%, and followed by ResNet 50, Vision Transformer, and GeoCNN. Uh, and These are my references. So I would like to say this study demonstrate that EfficientNet B0 is the most effective model for satellite image classification, because it provide excellent accuracy while and also remaining computationally efficient. So thank you so much.
Okay, Ranjit, so do you have something to say? Okay, I think there are no questions from his side. So let's move on with the next presentation. So next we have Rahul Dhaigude. Rahul, are you present?
Yeah, I'm there.
Yes, so he is here with us to present his work titled as Driving Change Management through the Implementation of Electronic Health Records the Cotter's Way. So, sir, you can start presenting.
Okay.
Yeah. I will request all the participants hereafter, please wrap your presentations within 9 minutes, because there should be time remaining for the question and answers and discussion of the paper. So yes, you can start, sir.
Thank you. I hope my presentation is visible.
Yes, it is visible.
Thank you. Good morning to all. So our presentation is on driving change management through EHR implementation the quarters way. Paper written by Shambhavi Pandey, Dr. Abhijit Deshpande, and myself, Dr. Rahul Dhaigre. So as we all know, the global trend is moving towards digital transformation, and it is being done in a heavy manner. This is being driven by the technology, and this is very much important for the speed and accuracy. We know that the healthcare profession is something where it is directly dealing with the humans, and any error or diagnosis or the care that directly impacts the human lives. It is very important for the healthcare institutions or the organizations to diagnose and keep the records of the patient correctly, so that all the care provided to the patient is correct. At the same time, it so happens that the patient has to visit the centers multiple times, healthcare centers multiple times, and those centers are different at different times, could be different at different times, and it becomes difficult to retrieve the correct records or keep the correct records and seamlessly integrate those records among the different organization, healthcare institutions or organizations. So this EHR talks about the electronic health records, which is the way of improving the quality of care, reduce the clinical errors, and enhance the operational efficiency by maintaining the correct data. However, this is not so easy. This is not so straightforward. It is not just digitization of the text into data form and just keep it there. It requires a lot of preparation, and that's why transformation of these records, healthcare records, into digital form is not so easy. So while the organizations are trying to go digital, transforming themselves into digitization, for healthcare industry, EHR, electronic health records, play an important role. There are many frameworks which talk about how you can, transform from one method to other method. But since the human elements are involved here, there are different frameworks, and that's why we try to implement John Cotter's 8-step leading change model. This is important because it talks or it takes into consideration the human aspect. If you look at the data in the global scenario, the success rate is from 30% to 80%, or you can say the failure rate of digital transformation of EHR is from 30% to 80%. It is staggering, it is alarming. So transforming some data into digital format for the healthcare industry is not that so simple. This is very important because the human and organizational dimensions play an important role. It's not just the technological capability that you got some technical guys understanding the data and the systems, and you are just implementing those things. It requires more than that. For this, what we tried to do is in India, we took up a study. It's a medium to small to medium size healthcare unit in Thane, and they tried to implement this implement through the Cotter's way the transformation of their digital records. So it's a single study, and it ran for 5 months, and it's a small period actually, but still whatever results we could assess, we try to got into those results and then analyze the Cotter's way, how efficient one can use the Cotter's 8-step methodology for the transformation. We tried to assess how each step translates into the correct outcomes, or if there are any barriers, if there are any challenges faced by the implementing people, and then we tried to see how they were addressed and how effective the transformation happened. So this was done at the High Tech Urology Center and Healthline Hospital at Thane. Definitely, it's a small scale, what you can say, investigation or implementation. We try to see how successful realization of the benefits of this, improving patient quality or reducing the errors or enhancing the overall efficiency through digital transformation takes place. Data, of course, there were people involved, so it was mainly the observation, since the people who were involved in maintaining those records, like there were administrative staff, there were accountants, or there were the physicians itself, how they were entering the data into it. So that was mainly the observation part. At the same time, the team sat with them and asked them the questions side by side. It was informal interview, you can say, because there was no structured way of asking them the questions. It was during the time of implementation, and then there were minutes of meetings, or there were health records, there were diagnostic reports, there were pharmaceutical reports. So all this data were used to analyze the implementation of this quarter's 8-step model. The period was from August to October 22. Actually, the process started well before August, but the actual implementation of entering the record started from the month of August. It went up till October, and then the post implementation follow up was done from November to January 23. So, this is the 8-step model which was applied at the center. Uh, there were 8 steps, as you can see. First is to create urgency, then build coalition. I'll just read the heading and then we'll get into each step separately. So create urgency, build coalition, then go for the strategic vision, communicate this vision to the stakeholders, empower their action, look at the quick and small wins. Those small wins then further lead to sustainable acceleration, and finally anchor in culture, or you can say institutionalization of the process. So for this particular case study, the first step was to create the urgency. This was to create the urgency among the stakeholders, like the administrative people, the physicians, and the accountants, since they were maintaining these paper records, and there were pain points. So for retrieving the record, it could take up to 30 minutes. Then there were storage constraints, because you have to use a lot of paper and files, and you have to keep it stacked on at some place. So these were the pain points, but since they were used to do all those things, it became important to tell the people and make them realize that yes, there is an urgency and there is a need to move from this paperwork to the digital data. So it was really difficult in the initial stages. As it is mentioned, change is very difficult for anyone to accept, and that took some time to address these stakeholders why it is important to move from paperwork to digital work. Once it was done, the second step was to build a coalition. That is, the agency which was there to implement this digitization was a third party vendor. And definitely the stakeholders and the third party vendors, all the people were not initially in the sync. So what was done is, two main stakeholders were identified as the coalition agents. They were admin managers and accountants who were quite good at using the computer systems. They were quite, you can say, the tech savvy people. And then they helped during the excuse me, vendor training to become a bridge between the end users at the urology center and the third party vendor. So during this period of time, this perceived ease of use among the skeptics, like we are not tech savvy, we don't know how to use the systems. These were the questions among the administrative staff or the accountants or the physicians, though the physicians were highly qualified, but using the computer systems, that they were skeptical about that. So the people within the organization, they were used as the bridging gap. After the initial training, then it was decided that to form the strategic vision. So what was the strategic vision? The strategic vision was to move from the paper to completely paperless organization. So this was the vision developed by the institution. So it was like you have to transfer from retrieving a file taking 30 minutes to going to a system and at the click of a button retrieve the whole data in front of you on the screen. So that was the vision which was shared among the stakeholders. After that, this vision has to be communicated to all, like administrative staff, physicians, accountants, and other people like pharmacists and other people who were working there.
Sir, sorry to interrupt.
Yeah.
You have 1 to 2 minutes
Yes,
left.
yes.
Yes.
Thank you. So it was not just the notification circulated among the people that we are going from paper to paperless. The management went and meet with each and every person and communicated this vision to them personally. So there were different benefits that were seen because of this individual communication. So there were less problems they were being faced for scheduling the appointments of the patients, immediate record retrieval, no problems, or virtually you can say no problems in billing analytics and tracking of the invoices. So when the different peoples are involved and they were being talked by the management, they got to know that these are the important things which were driving the efficiency of theirs. Going ahead, then for the training purpose, the dummy patient records were used because they were skeptical if we make a mistake in patient's record, that would be a fatal thing. So dummy records were used, YouTube videos were given to them as a trial. So it was a separate environment created for them to practice, and then they got some confidence that okay, we can do that, and they overcome the anxiety of that we are not tech savvy, how could we manage those things. Later on to okay, we can work on the dummy records and then we can manage our work. After this, then the actual implementation started from August, and in the short period of say 2 months, the lab integration and addition of euroflowmetry reports, they were validated. So it was a successful implementation after the 2 months of short training. The stakeholders got confident of okay, they can work on the systems, and then this further sustained the acceleration, and the monthly review meetings were being held to check what is the progress, what is the process, if there are any challenges, if there are any barriers being faced by the stakeholders, and they were immediately being addressed by the management. And after 5 months post implementation, the full migration from the paper to HR was done, and then the staff stopped from questioning like why must we implement EHR if we are very good at doing the paperwork, to okay, we work this way, we work on the systems only. So this was the way in which they transformed from paper to paperless. These are the outcomes. So on the left hand side, outcome dimensions were the challenges and pre and post changes. So patient file retrieval would take 30 minutes. It was less than 2 minutes. Diagnostic reports were manual paper based. They became automated, lab and euroflowmetry integrated. Billing process was manual. There could be errors. It went to digital billing with tally integration. Storage, of course, expanding physical racks were there. They, they were done away with that, and they went to the cloud or server based filing system. Staff resistance, initially it was high because of the physicians. They thought that okay, If we keep on entering the data into that, it would take a lot of time of our consultation. But after that, since they were used to doing or entering this data into the systems, they were happy with that, and it went down to minimal. Missed appointments because of the manual scheduling, there were errors. They were reduced with EHR because there were digital informations uh, available. And then the cultural orientation. This is the complete change from paper centric to digital. So main challenges were, it was not technical thing, it was social challenge. Like people were skeptical. They needed to tell about what was the urgency, what was the importance of moving from paper to paperless. Then small things mattered. People used to celebrate the small wins, achieving small single goals, and then it translated into the larger goals. Clinical fit drives physicians buy in. Okay, initially the physicians were skeptical, they were reluctant of using those things, but when they came to know that this euroflowmetry reports were integrated seamlessly, they were happy about that. And contextual customization was about the training with the dummy data, which helped transform this. What we could learn from this case is the champion identification is non-negotiable in resource limited settings. So you need someone to drive the people, that is the management, which is champion. You need
Excuse
to
me, sir.
create urgency. I'm
Doubt,
done,
sir.
1 minute.
You are
uh,
already 2 minutes late, sir.
yes sir, I'm
Can you
done.
come to the conclusion?
So the digital transformation is something which is very much important in the healthcare sector, and this leads to the digital transformation and transformation of organizations. Thank you so much. Any questions?
Questions for him?
Yeah, no
Okay.
questions. So nice presentation.
Yes.
We can go ahead
Great.
with the next part.
Thank you.
So next we have Anna Alvarez Sanchez. Anna, are you present? Let me check once if Anna's present. Any of his co-authors is present? Okay, so let's move forward with the next one. So next we have Anuja Zadhav. Anuja, are you there?
Yes, ma'am.
Yes. So she is here to present her paper titled as Leaf Disease Detection Using Artificial Intelligence. So Anuja, you can start sharing your screen. Also, I request all the participants, please be on time as we are short of time. Uh, the point of the presentation is to organize your core idea and not the whole backstory and everything. So I request everyone to please uh, be on point about the presentations. So yes, you can start.
Ma'am, is it okay if all three us present the PPT?
Yes, sure. You can do as you think.
Okay, ma'am. Thank you. Good morning, everyone. Respected chairpersons, honorable conference committee, and researchers, and all the participants present here. I am Miss Anuja Arun Zadav from the Department of Electronics and Telecommunication Engineering, Vishwakarma Institute of Technology, Pune. Today, I am placed to present our research work title, that is Leaf Disease Detection Using Artificial Intelligence for Sustainable Agriculture. This work focuses on applying artificial intelligence and deep learning techniques for earlier detection of plant diseases, which is can help farmers to improve crop productivity and support sustainable farming practices. Along with my co-authors, co-authors, Miss Manasvi Shipte and Mayuri Chinchole, we have explored an AI-based approach for automatic disease identification from a leaf image. So let me begin with my introduction of our research topic. So, agriculture plays a vital role in ensuring food security and supporting the livelihood of millions of people worldwide. However, plant diseases are one of the major challenges affecting crop productivity, quality, and farmer income. Traditionally, diseases identification is performed through manual inspection by agriculture experts. Although effective, this method is time consuming, requires expert knowledge, and may not be easily available in rural areas. Due to these limitations, earlier detection become difficult, resulting in disease spreading and significant crop losses. Artificial intelligence, especially deep learning based image processing technique, provide an efficient solution by analyzing leaf image and identifying disease pattern automatically. Our proposed approach aims to provide fast, accurate, and scalable detection using AI. According to various studies, plant diseases contribute $2 billion of dollars in annual crop losses globally, and delayed diagnosis can significantly reduce yield. Therefore, an AI-based detection system can play an important role in a sustainable agriculture. Next slide, please. Okay, in this slide, we see the why traditional detection falls short. The main problem addressed in our research is the limitation of conventional plant disease detection method. Currently, farmers mainly depend on visual inspection, which has several drawbacks. Firstly, it requires trained agriculture experts, which may not always be available, especially in a remote farming region. Secondly, manual observation depends on human judgment, which can lead to inconsistent results. Another major issue is scalability. Inspecting large agriculture fields manually requires significant time and effort. Also, delayed identifications allows diseases to spread, affecting crop health and productivity. To overcome these challenges, our approach uses AI based automated detection, where leaf image can be analyzed quickly and disease classification can be performed without requiring expert innovation. Next slide. So now in this slide, we see the research objectives. The main objective of our research is to develop an intelligent system capable of detecting plant diseases accurately and efficiently. The key objectives are as follows. First, earlier detection to identify diseases symptoms at an earlier stage so that farmers can farmers can take preventative actions before major crop damage occurs. Second is high accuracy to achieve reliable classification performance under a different lived conditions. Third is a real time prediction to provide diseases detection result within a short time period, which making the system practical for field application. Fourth one is a cost reduction to reduce dependency on expensive laboratory testing and expert consultation. Finally, the finally sustainable farming to support farmers with data driven decisions and promote efficient use of agriculture resource. Overall, our aim is to create a scalable AI based solution that connects precision agriculture with sustainable crop management. With this background and research motivation, I would now like to hand over the presentation to my teammate who will explain the system architecture and methodology of our proposed approach. Thank you.
Good afternoon, everyone. Before starting our project, we studied the different research paper to understand the how AI is used for the plant disease detection. Earlier, the researchers used the CNN models, which have the good accuracy for the image classification. After that, a ResNet was introduced. It solves the problem for the of training very deep networks and improve the accuracy. Next is the efficient net. It becomes a popular because it provides the high accuracy while using the fewer computations. Next is a mobile net. It is another lightweight model that works well on the smartphones and other low power devices. Recently, the researchers also started using the vision transformer, which provides the excellent accuracy, but it requires the more powerful computers and takes the longer to train. From our study, we found the one important research gap. Most existing models, which that works on very well on clean laboratory images, but their performance decreases when the image is taken from the real farms, backgrounds, and different crop varieties. From our work, our work aims to make that the disease detection more practical for the real life agriculture environment. Next slide is next is the system architecture. This slide shows the complete working process of our system. First, the farmer captures the images from the plant using the smartphone. Next is the image acquisitions. This is a processed. In this step, the image is resized, cleaned, and normalized so that the all images have the same quality and the size. After pre-processing, the image is given to the CNN model. CNN model analyzes the images and learns the important features such as the leaf color, texture, and the spot disease pattern. Based on these features, the model predicts whether the leaf is healthy or affected by the some disease. Finally, the detected disease and recommendations are displayed to the farmer through the application. Next slide is the methodology. Our methodology consists of the 6 simple steps. First is the data collection. We collect the data more than 54,000 leaf images from the plant village dataset and the real field conditions. Next is the second
Guys,
process.
you need to conclude in next 2 minutes, okay?
Okay. Next is the pre-processing. Pre-processing image is resized normalization. Third is a training. We use the CNN for the model training. Fourth is a testing. About 20% of images were kept for the testing. Fifth is the evaluation. And sixth is the deployment. Next is the CNN architecture. This diagram shows how the CNN model works. First the input of leaf image is given to the model. Then the first layer of detects simple features and edges. Middle layer identifies the texture and shapes. The deeper layer recognizes the disease pattern, and finally, softmax layer calculate the probability of each disease. Next, the Mayuri will explain. Next slide.
Now, I would like to present the results of the proposed model. To evaluate our model, we used 5 evaluation metrics. Accuracy measures overall, we can see that the accuracy measures overall correct predictions. Precision measures how many predicted disease samples are actually correct. Recall measures how many actual disease cases are we successfully detected. Then the F1 square balances precision and recall. Our proposed model achieved accuracy of 98.2%, precision 97.9%, recall 98%, and the F1 square as 97.95%. The confusion matrix further confirms that only a very small number of samples were misclassified. These results demonstrate that our model performs reliably for disease classification. Next slide. So now the sustainable development. After discussing the performance of our model, our work contributes directly to the United Nations Sustainable Development Goals. It supports hunger by increasing agricultural productivity. It supports industry and innovation through AI adaptation. It supports responsible consumption by reducing pesticide overuse. Finally, it supports climate action by increasing sustainable farming methods. Next slide. So, I would like to discuss the key advantages and current limitations of our proposed system. The proposed system has several advantages. It provides predictions in less than 2 seconds. It is inexpensive because only the smartphone is required. It can deploy it on mobile devices for field use. Next slide. Moving forward, let me briefly discuss the future scope of this research. In future, we plan to integrate drone monitoring for large farms. Satellite images can provide regional disease prediction. IoT sensors can collect humidity and the temperature data. Then we can use Edge AI, we will allow complete offline operations. Explainable AI will help users to understand why the model is predicted a particular disease. Then we can use ESP32 based embedded systems can make the solution low cost and portable. Next slide. Lastly, I would like to conclude my presentation by summarizing the key findings of our research. In conclusion, our proposed AI-based leaf disease detection system demonstrates that deep learning can significantly improve the disease diagnosis. The system achieves 98.2% accuracy and reduces the diagnosis time, supports sustainable agriculture, and helps the farmers timely decisions. Future improvements will further increase robustness and the real farming conditions. Thank you.
Ranjit sir, do you have any questions for them?
Yeah. Hi. So how you have prepared the data set? Since you have created a real-time data set or you have used the existing one? Hello, am I
Yes,
audible?
Yes, you are
yes.
audible.
So we take the dataset from Kaggle and add some our images from real agriculture.
Okay. Have you deployed this model online on cloud platform?
Yes, sir. In last year we deploy this.
Okay, good. Nice presentation, Anuja. Best luck. Thank
Thank
you.
you, sir.
Okay, so coming up next, our next speaker is Suruchi Pandey. Ma'am, are you present? Or any of her co-authors is present on behalf of her? Okay. Okay, I think she is not present. So we will move to the next one. So next speaker is Hemlata Gaikwad. Ma'am, are you present? Or any of her co-authors is there? Okay, I think she is also not there. So next, Anna Alvarez. Anna, are you present? Okay, so she is also absent. Then we have Viraj Chitragar. Viraj, are you present in the meeting?
Yes,
Yes, so he is going to speak on MQTT driven arterial hemodynamics digital twin, particle simulation velocity gradients, and WSS FFR indices in the browser. So, Viraj, you can start sharing your screen.
okay, sure. Is my screen visible?
Yes, it is visible.
Yeah, okay. Good morning, everyone. I'm Viraj Satish Chitragar, and today I'm presenting my project titled MQTT Driven Arterial Hemodynamics Digital Twin. This work basically focuses on creating a browser based digital twin that can simulate blood flow inside arteries in real time, allowing users to visualize important cardiovascular parameters without relying on expensive and time consuming CFD softwares. Uh, for the introduction, cardiovascular disease is one of the leading cause of death worldwide. We are aware of that, and one of the major reasons is arterial stenosis, where here the blood plaque builds up inside arteries and restricts blood flow. Traditional engineers and doctors use CFD softwares like COMSOL or ANSYS to study blood flow. However, these simulations usually take several hours because of processing, meshing, and numerical solving. Our idea was to overcome this limitation by creating a real time browser native digital twin. Here, in our project, we have created one side of the digital twin, and the second part, which was the physical part, is yet to be developed and is under process of 3D printing of arteries using uh, biomaterial, like biological material. Okay. Instead of waiting for hours, users can instantly visualize blood pressure and blood flow, the wall shear stress, and plaque risks interactively on our browser-based simulation software. This makes the system useful for education, rapid analysis, and demonstrating cardiovascular concepts. The problem statement here was to bridge the gap between slow offline CFD workflows and the urgent need for interactive real-time assessment of arterial hemodynamics, wall shear stress-based risks, and lesion significance. There were main objectives that was to develop a browser-based digital twin, compute important hemodynamics parameters such as velocity, pressure, wall shear stress, TAWSS means time average wall shear stress, OSI, RRT, FFR, and wall stress. It allows user to change inlet flow, artery geometry, and stenosis severity interactively. To integrate MQTT. MQTT is basically a message queue telemetry transportation where we can control the parameters of the simulation, or in basic words, we can say uh, controlling a game using a console. So that is what MQTT does. So to integrate MQTT, so external scripts can automatically control simulations, and to provide an easy to use educational platform that complements high fidelity CFD tools. There was some literature survey that we did before developing the system. We studied several important research papers. The literature consistently shows the parameters such as wall shear stress, TAWSS, OSI, and relative residence time that are strong indicators of plaque formation. Research also validates a fractional flow reserve, or FFR, as an important clinical indicator for determining whether a blockage is severe enough to require intervention. Well, these studies formed the scientific foundation of our project, and guided the metrics we implemented. Uh, this is the system model basically, uh, and this is the overall architecture. The front end is developed using React and 3JS, which are the libraries of JavaScript, which renders the interactive 3D R tree. The computational core here is written in JavaScript and performs reduced order blood flow calculations directly inside the browser. An MQTT bridge, it connects the simulator with external scripts and dashboards. The solver that is coded in JavaScript, it computes the velocity, pressure, wall shear stress, TAWSS, OSI, RRT, FFR, and wall mechanics. These, which are repetitively appearing or repetitively said uh, terms, are highly responsible for identifying if there is a plaque in the artery or not. Since everything runs locally inside the browser, there is no server dependency, resulting in very low latency and real-time interaction. Next, in the implementation is based on simplified fluid dynamics. The blood flow solver uses the incompressible Navier-Stokes equation. This is the equation. The wall shear stress measures the fractional force exerted by blood on the artery wall. And here is the equation that we used. TAWSS calculates the average wall shear stress over one cardiac cycle. FFR is computed as the ratio of distal pressure to proximal pressure, where values below 0.80 generally indicates clinically significant stenosis. For wall mechanics, we use the Holzapfel, Gasser, Ogden, or HGO model to estimate circumferential stress and strain. To improve performance, the computations are GPU accelerated using WebGL shaders. It is an in-browser add-on or a library, we can say, which helps us render or compute the normal rendering of platforms uh, faster, enabling sub-second execution. Okay, that's what I said. And okay, these are the uh, references to the equations and their uh, papers. This is the result. I'll just play it. So this is my screen recording actually that I have pasted. Is it visible clearly? Hello?
Yes, sir,
Yes.
it is clearly visible.
Yes.
Okay. So this is the model that we actually input into the simulation software. And these particles that you see is basically the blood flow. Here, the red or the orange color indicates that the blood is entering with a high pressure. And here on the tip, you can see that the inlet velocity or the pressure is higher. Now, this is the basic simulation that is going on. And here, the stenosis is visible on this region where we can see gray part here bulging inside. So we can increase or decrease the inlet velocity and pressure, and based on that, the flow will be occurring. So this is the velocity gradient. We can see or observe that on the stenosis part, the velocity is higher, and the MQTT comes here now. Now this is my second device which will act as a console, and whatever input parameters that I give, based on that the simulation will occur here. So this was generally created or coded to control both the uh, models, correct, both the models like the software model and the physical model, which is in implementation stage right now. Later on, after doing all this, these are the images. This shows the blood particle simulation, the velocity gradient at stenosis, and wall shear stress here, the stenosis part. Later, we get these research metrics that we generate from the simulation here. And these are the hemodynamic parameters that are responsible for a doctor to diagnose if the artery is in a good condition or if it is in a bad condition. So here the TAWSS, which is time averaged wall shear stress, is the average shear stress during a heartbeat. Low values are associated with plaque development. Next comes the OSI. It measures how frequently the blood flow changes direction. High OSI indicates disturbed flow that can damage endothelial cells. RRT is relative residence time. It is the estimates how long blood particles remain near the vessel wall. Longer residence time increases plaque formation risks. FFR, the fractional flow reserve, it compares pressure before and after stenosis. Value close to 1 is normal, while value below 0.8 indicates significant blockage. Finally, HGO stresses estimates the mechanical stress experienced by the artery wall, helping assess the rupture risk. There is contribution of this project to the recent available projects that are the heavy softwares that we use, such as COMSOL and ANSYS Flow. So the major contributions of these projects are, first we developed a browser native reduced order hemodynamics solver capable of running in real time. Second, we implemented clinical relevant plaque risk metrics such as TAWSS, OSI, and RRT, which we cannot in ideally code this using basic mathematics. We need to refer many papers, their understanding, and equations to do this. Third, we designed an interactive digital twin where users can instantly modify artery parameters and observe the results, which where comes the MQTT's role. Fourth is the integration of MQTT, which enables automation and remote control of simulations. Finally, we incorporated non-linear arterial wall mechanics using the HGO model to prove realism. The model that is uploaded on the software is not just a solid model. The model that is uploaded, the walls will get the uh, features or properties of a real time or real artery that is in our body. So the HGO model is uh, made or a mathematical formula for this non-linear arterial wall mechanics. Coming to, okay, these are the contributions that I just said. Coming to the conclusion, our browser native digital twin, it combines blood flow simulations, wall mechanics, and clinically relevant hemodynamic metrics into one interactive platform. Uh, the system, it provides immediate visualization, and we do not require expensive CFD softwares. Well, it makes it valuable for research, education, and preliminary cardiovascular analytics. Uh, and for the future scope, we plan to support patient specific artery geometries, improve fluid structure interaction, extend MQTT for collaborative multi-user simulations, and integrate machine learning models for automatic cardiovascular risk prediction. Okay, that's it. And also you can see that I am from KLE Technological University. KLE owns the biggest hospital here in Karnataka, that is GNMC. And they also do the same simulations on the patients. They take their MRI data of the arteries and study if how healthy their artery is. So that is our next step in future, which is we take in the data, MRI data, and we can generate a 3D model out of it, out of that artery that is, uh, you know, not good, not in a good health, and put it in our software and analyze the further predictions, like if this patient's artery will be healthy in the next 10 years, or how will it behave in next 5 years. So based on today's data or the past 5 years data, we can predict what that patient may suffer or might not suffer in the future. So that's it. Thank you for your time. If there are any questions, you can please ask them.
Ranjit sir, any questions?
Are you using this software in the hospital right now?
No, it has to be approved by many scholars first, since they have to see if we are using the correct calculative formulas or not. This is still in the developing phase, like almost the software part is developed and the physical part is yet to be developed. That's why we are waiting for the approval to deploy it in the production.
Okay. Best of luck. Thank you.
Thank you, sir.
Okay. Thank you so much, Viraj, for presenting. So here comes the last presentation for today, and we have Shravan Sai S. Shravan, are you present?
Yes, ma'am.
Yes. So he's going to speak about sustainability communication of luxury fashion brands, a deductive content analysis using the triple bottom line framework. So Shravan, you can start. Shravan, are you hearing? Yes. The screen is visible, but the presentation is not visible.
Can you hear me, ma'am?
Yes, the presentation is not visible, but the screen is shared, but the presentation is not visible.
Now it's visible, ma'am, the presentation.
No, actually, what you have to do is when you click on share, then you have to click on the presentation window.
One
Try
second,
it
ma'am.
again. Yes.
Now it's visible, ma'am. Now?
Yes, it is visible. You can start.
Yes, ma'am. Yes. So, good morning, everyone. So, today I'm going to present our research title Sustainable Communication of Luxury Fashion Brands, a detailed content analysis using the triple bottom line framework. So, the luxury fashion industry has traditionally been associated with exclusively superior like craftsmanship, premium quality, and
Are you
heritage.
moving the slide, Shravan? Because the movement is not visible.
Yes, ma'am.
The movement is not visible. Movement of slides. Yes.
Now, ma'am.
Just keep it. Yes. Just keep it that way, and you can
Yeah.
change. Yes.
Yes. However, in recent years, the sustainability has become an equally important aspect of luxury branding. So, consumers today are not longer interested on beautiful products. They also want to understand how the products are made, how makes them, and what impact they have been on society and the environment. So, in today's digital era, official brand websites have become one of the most important communication channels. So they are not merely promotional platforms, but also spaces where brand communicates their sustainability initiatives and ethical values and environmental commitment and support for the communities. So our research exposed how an Indian luxury fashion brands communicate these sustainability messages through their official websites and how these narratives contributes to the contributes to the building and brand authenticity and the uh, positioning. So our research gaps is that although sustainability is becoming widely focuses on either sustainable production practices or consumer purchasing behavior. Only very few studies examine how the luxury fashion brands actually communicate sustainability to their stakeholders, especially through their digital platforms. That's the most important thing. And also, there are limited research focusing on specifically on luxury fashion brands, since our India has a fashion luxury fashion industry is deeply connected with traditional craftsmanship and artisan communities and cultural heritage. So our study addresses this gap by analyzing the sustainability narratives communicated through official brand website using triple bottom line framework. So our research objective is that the main objective of our study is to understand how Indian luxury fashion brands communicate sustainability through their website of officials. More, we aim to identify the sustainability related content and classify these narratives under the three dimensions of triple bottom line is people, planet, and profit. So here the people which focus on social sustainability, planet stands for which focus on environmental sustainability, profit which focus on economic sustainability. So these framework actually enables us to systematically evaluate whether the brands maintain a balanced approach while communicating sustainability to the brand websites. So our literature review is that our literature review indicates the sustainability communication in luxury fashion differs significantly from fast fashion because luxury brands generally focus on craftsmanship, heritage, artisans empowerment, and product longevity rather than they simply highlighting the environmental status. So, the previous studies and all suggest that our consumers authentic storytelling more positively than technical sustainability claims because the narratives related to traditional skills, culture preservation, and communicate community development often create stronger emotional connections with the consumers. So the conceptual framework is triple bottom line framework. So the study adapts John Ellington's triple bottom line framework, which evaluates sustainability across three interconnected dimensions. So the people, which focus on social sustainability through artisan empowerment, education, community development, and fair employment. The planet, they focus on environmental sustainability through eco-friendly materials, responsible sourcing waste, and detection, reduction, and sustainable production. Profit, which focus on long-term economic sustainability by creating market value with supporting artisans. So the research methodology is we are adopted and exported qualitative research designs because our objective was to understand communicate patterns rather than establish statistical relationships. So we selected three Indian luxury fashion brands and collected sustainability related content from their official websites. So data were analyzed during detective thematic analysis. So instead of allowing themes to emerge randomly, we first developed the theoretic coding framework. So during coding process, we continuously refined and validated the themes, ensuring that both theoretical concepts and newly emerged insights were incorporated with the analysis. So the research products was the selections of Indian luxury brands, their official website content collections, then the website content organizations, then detective coding people, planet, profit, inductive theme retainment, thematical analysis, and interpretation of the sustainable narratives. Then the codebook development comes. So here the codebook are three important people. So people come for artisan empowerment, then education, community, and welfare. And the planet will be sustainable materials, waste reduction, responsible sourcing. Then the profit is heritage branding, arts and livelihood, and long-term value. So the findings are people, social sustainability. So our analysis revealed that people dimension receives strongest emphasis across all three plans. The website constantly highlight arts and welfare, women's empowerment, preservation of traditional craftsmanship, skill development, education, and community engagement. Send the planet environmental sustainability. So the environmental sustainability was communicated, but comparatively less extensive than the social sustainability because brand mentioned initiatives such as responsible sourcing, sustainable materials, waste reduction, eco-friendly productions, and environmental conscious designs. However, detailed environmental performance indicators and measurable sustainable metrics were relatively limited. Then findings of the profit. So the profit dimension focused on sustainable economic value creation. Brands highlighted how handcrafted luxury products support artisan livelihoods, and also by combining traditional craftsmanship with global luxury positioning. And also these brands generate a long-term business growth without compromising cultural authenticity. Then we have the sustainable development goals that gender equality, decent work and economic growth, responsible consumption and protections, and also life on land. Then the discussions that one of the most interesting observations from our studies that Indian luxury fashion brands primarily communicate sustainable through stories rather than technical sustainability reports. Their communication emphasizes heritage craftsmanship, artisan communities, and culture preservation. However, the comparatively limited emphasis on measurable environmental outcomes suggests an opportunity for brands to improve their transparency and strengthen overall sustainability communications. Their research contributions is that the theoretical contributions is that theoretical it expands a literature on sustainable communication in context of Indian luxury fashion. Methodologically, it demonstrates an effectiveness of detective thematic analysis for analyzing website-based sustainable communication. Practically, it provides valuable insights for luxury fashion managers by highlighting the importance of authentic storytelling while encouraging a more balanced communication strategy across all the dimensions of the system. So the last to conclude to our research paper, our research shows that Indian luxury fashion brands primarily communicate sustainability through narratives centered on people, heritage, and cultural preservation. While environmental sustainability is certainly acknowledged, social sustainability remains the dominant and communication theme. This authentic narrative strengthen brand credibility, reinforce luxury positioning, and also contribute to a long-term sustainable competitive advantage. Ultimately, our study highlights that effective digital storytelling has become a strategic tool for communicating sustainably in luxury fashion industry. And the last managerial implications, from a manager perspective, luxury fashion brand should strive to maintain a balanced, sustainable communication strategy. While storytelling, artisans, and cultural heritage are highly valuable, but brands should also communicate measurable environmental achievements more transparently. Managers should therefore integrate people, planet, and profit equally into their digital communication strategies to strengthen the both competitive positioning and also long-term stakeholders relationship. Thank you for your kind attention, and I would be happy to answer to any questions.
Hello, Yashida.
Ranjit sir, any questions for him?
I think Sarah is facing some technical glitch. That's why he is not available in the meeting right now. So you can just wrap up the meeting and conclude.
Okay, sure, sure. So this was the last presentation for today, and we have come to the end of this session. So I sincerely thank all our authors for their excellent presentations and valuable contributions, and all the participants for being an important part of this international conference. So I truly hope that this session was insightful and engaging for everyone. So on behalf of the entire team, we thank you for your continued support, not just for this edition, but for all the previous editions of this conference. So we look forward to welcoming you all again in the next version in 2027 as well. So all the presenters will be receiving their digital certificates via email within 2 working days, and the publication will be live within 7 to 8 months. So we kindly request your cooperation with our team. I would also like to extend my sincere thanks to our session chair, uh, Ranjit sir. I think he's facing some sort of issue. So this is the token of appreciation on behalf of Team ICT4SD and Global Knowledge Research Foundation and partners. So thank you all for once again for all for your valuable presence. And before we officially wrap up, we should click this as a memory. So I request everybody to please switch on their cameras so that I can take a quick snapshot of this conference. So please everyone s- turn on your cameras. Okay, thank you so much everyone. Stay safe, take care everyone. Thank you for presenting yourself. Thank you.